In this lesson, we'll be building this food diary app. The app lets you add and keep track of different foods you've eaten. We'll start with the basics of displaying the list of foods and adding new ones. Then in the challenge, you'll add the ability to swipe to delete foods from the list. Then in the next lesson, we'll continue building this app to add more features. So start Xcode and create a new project to get started. We're going to start this app from the empty application template, so you can see how apps work when they start up. Let's call the app Food Diary. Make sure automatic reference counting is checked, then click Next to create the project. This is the most basic app structure. There are no view controllers or views. All we have is an app delegate class. An app delegate handles the starting and shutting down of the application. Here you'll find methods to customize the app when it's starting up and customize the behavior of the app as it enters different states. You can read in the comments here what events trigger the application to enter the different states. For example, I might want to save all my data when the app is about to shut down. I could write code to do that down here in the application will terminate method. One of the first methods to get called in an app is the application did finish launching with options method. Xcode already filled in some boilerplate code for us that sets up the app window. An app window is what holds all the views that we make in Interface Builder or storyboarding. So let's go ahead and add a storyboard so we can get started laying out our app. Go to File, New File. Go to the User Interface section and select Storyboard. Choose iPhone for the device family and click Create to create the storyboard. So this is an empty storyboard file. In this app, I want to navigate back and forth between different views using Apple's standard navigation bar. So the first object I want to create in the user interface is a navigation controller. So I'm going to drag that from the objects library. The first view I want to show in our app is a table view. A table view is the standard iPhone view that displays a list of information like the iPhone's phone app that displays all your contacts. This view that came with the navigation controller is just a normal view. So I'm going to highlight that and then hit the delete key on my keyboard to delete it. Now I'm going to drag a table view controller from the objects library. And I'm going to make that the first view that shows up in the app by holding the control key and dragging from the navigation controller to the new table view controller, and then selecting relationship root view controller. Now I need to inform my app that I want it to show this storyboard file when the app starts up. To do that, we'll go to the project settings, and in the summary section, go down to the main storyboard setting and select our storyboard file. Now that we have this setting set to a storyboard file, when the app starts up, it will see this setting and automatically create a window and then add the first view from our storyboard to the window. So now that that's done automatically, we can go back to our app delegate file and then delete all this code from the application did finish launching with options method, since this is all done automatically now. Delete everything here except for this return yes line. We can see here that this method has to return a boolean, which is a yes or no value. That boolean lets our app know whether or not the app should actually start. We don't have any reason to not let the app start, so we'll always return yes. Now run the app. And we can see that we have our table view controller as the first view, and it's displayed inside a navigation controller. Great. Now let's make our table view display some information. Go back to the storyboard file. Make sure the table view is selected and click on this yellow circle under the table view. Now select the Identity Inspector. Here we can see that this yellow circle represents a UI table view controller object. Just like in the last lesson where we created a custom view controller to control our view and everything in it, in this lesson we'll create a custom table view controller, and that will control this table view and everything in it. Click on the Connections Inspector. Notice that our table view controller has an outlet to a view, and when we mouse over that outlet, we can see that it's our table view in the storyboard. So we know that this UI table view controller object is the object that controls our table view. So when we want the table view to display information, we'll control that with the UI table view controller. The only problem now is back over in the Identity Inspector. A UI table view controller is one of Apple's classes. We can't write code in the UI table view controller files because we don't have those files. So we have to create a subclass of UI table view controller that will customize its behavior. To do that, go to File, New File, select Cocoa Touch, and since UI table view controller is a subclass of UI view controller, we'll select a UI view controller subclass. Let's call the class TAD Food Table View Controller. And make sure to make it a subclass of UI Table View Controller. Click Next and create the file. So now we have a new class called TAD Food Table View Controller. Back in the storyboard file, we need to change this UI Table View Controller object into a TAD Food Table View Controller so that we can write code for it in the files we just created. To do that, make sure this yellow circle is selected and go to the Identity Inspector and change the class from UI Table View Controller to TAD Food Table View Controller. If you ran the project now, everything would look exactly the same as it did the last time we ran it, and that's because our new TAD Food Table View Controller class that we just created is a subclass of UI Table View Controller. And our new class does everything that UI Table View Controller does. Since we haven't customized any of the methods yet, everything's going to behave exactly like a UI Table View Controller. Before we start writing code, we should note that there's also something special about table views. Click on the Connections Inspector. Notice the special referencing outlets here called data source and delegate. A referencing outlet is another object that has a connection set to this object. These lines tell us that TableView has its data source and delegate properties set to this Food Table View Controller object. When an object sets a delegate like this, that just means that the object is going to inform its delegate of certain changes or ask the delegate for more information. So normally our Food Table View Controller would just tell our table view what to do by calling the TableViews methods. But here, since TableView has set its delegate to our Food Table View Controller, the Food Table View Controller will also have to respond to the table view when the table view asks it something. The data source works in the same way, and the way we make the delegate and data source work in our code is we have to write specific methods that UI table view is going to ask. Lucky for us, it just so happens that Xcode already filled in those methods for us when we created the TAD Food Table View Controller files. Check out the .m file. These three methods are methods that UI table view will ask its data source. And this method at the bottom is a method that UI table view will ask its delegate. Since this object is set as the delegate and data source for the table view, we can customize these methods to control the table view. The first method is the table view asking how many sections it should have. We can write code here to determine that dynamically based on data we have, but for now, let's just see how everything works. So we'll type 1 for one section. And let's also delete these warnings that Xcode has put here to inform us that we need to customize these methods. For the number of rows in the section, let's return 3 to make our table have 3 rows. This next method is a method that the table view asks for every row. So since we have 3 rows, this method will be called 3 times when the table view is loading. Each row in the table is called a table view cell. And we can see here that we need to return a UI table view cell object at the end of this method. Before we write code to return a cell, let's go back to storyboarding and set up how we want our table view cell to look. Click on the table view cell and go to the attributes inspector. Look at the different styles of cells. We can create our own custom cell, but for now let's just go with basic. And let's name the cell basic cell with the identifier property. Now go back to the table view cell for row at index path method we were just looking at. Table views will save unique cells that have been used and then reuse those cells when they're creating a new cell. That's what this DQ reusable cell with identifier method does. It's saying that we want to reuse a cell called cell identifier, and up here the cell identifier variable is a string called cell. Let's rename that to basic cell so that the method will use the cell that we just set up in our storyboard. These next lines of code create a new cell if there's not one available to reuse. But if you create your cell and define it in storyboarding like we did, then that cell is automatically saved as a reusable cell. So we can actually delete these lines of code. So now that we have a UI table view cell object, we can set it up to display information. All of Apple's table view cell styles have a text label that can be accessed through the text label property. So we can get the text label by typing cell text label and let's set the cell's text label to be hello by typing set text hello. Then this return line will give the cell back to the object that called this method, which is the table view. So now we can run the app, and we see 3 cells with the word hello in them. Now I want to introduce you to a function that will allow you to do some basic debugging when you have a problem with your app. And that function is called nslog. nslog is a function that will write information to our debugging console. So if I go to the cell for row at index path method, and I type nslog table view is asking for cell, now when we run the app, when that method is called, our debugging console will display the string that we just typed in. The debugging console is down here at the bottom, and if yours doesn't show up automatically, you can toggle it in and out with this view button. So our string is displayed 3 times in the console because this method, cell for row at index path, is called 3 times, 1 time for each row in the table. nslog can also accept the formatted string. So we can put a placeholder in this string and then add code after it to display a variable. I'm curious if the table view loads starting at the top cell or starting at the bottom cell. So to find that out, let's display the row number that the table view cell needs each time it calls this method. When the table view calls this table view cell for row at index path method, it passes in objects that we can use. One is the table view object that's asking for a cell, and the other is this index path object. An NS index path can describe complex paths through multiple objects, but we really just want to know the row that we're in, and to do that, we'll use the index paths row method. The row method will return an integer that indicates which row we're in. So now that we've added that code to our nslog method, let's run the project and see what our console says. And we can see here that our table view asks for the cells in order 0, 1, 2, where 0 is the first row and 2 is the last row. Now let's start filling in our table view with more meaningful data. We'll do that with an array. An array is an object that holds a list of other objects and keeps them in order, which is perfect for our table view. Apple's class for an array is called NsArray. We'll have to access our array from several different methods in our class, so let's create a variable in our header file for the array. We'll do that with the @property declaration. Before, we created variables like this by dragging from Interface Builder. But since an array isn't a user interface object, we have to type out code ourselves. Non-atomic and strong are two properties of this variable. For the first one, we can either choose atomic or non-atomic. We choose non-atomic when we won't be accessing this variable on multiple threads, and we would sometimes choose atomic when we would be accessing the variable on a different thread. If you don't know what that means, that's okay. Threads are an advanced topic, so just stick with non-atomic for now. For the second attribute, we can choose strong or weak. Now's a good time to talk about when to use strong and when to use weak attributes when you're declaring properties. When you write code to create an object, you're making space for it in memory. Not the disk memory like the 16 gigabytes you have if you bought a 16 gigabyte iPhone, but a different type of memory, which is the iPhone's random access program memory. If your app causes the iPhone to run out of this type of memory, the iOS will force your app to crash so it can reclaim that memory. So it's important that your app doesn't keep objects for longer than it needs them. That's where these strong and weak attributes come in. They tell iOS when it's okay to remove an object from memory. Here we said that we want our food table view controller to have a strong reference to this food array property. Strong indicates that as long as this food table view controller is being used by the app won't get rid of the food array object. If we chose weak property, that means that iOS could get rid of the food array at any time, even if the food table view controller was still being used by the app. So why would we ever want to make a property weak? One case is this. Suppose we have one view controller object that has a strong reference to another object, and that other object has a strong reference back to that view controller object. When the app no longer needs the view controller object, the view controller can't be removed from memory because iOS thinks that the view controller is still needed by that other object, when in fact the other object is no longer needed either because that other object was only needed by the view controller. If you do this too often in an app, it may crash from running out of memory. The proper way to handle this is to have the other object have a weak reference back to the view controller. That way when your view controller is no longer needed, there are no longer any strong references to it. An important rule to remember is that iOS will remove any objects that don't have strong references. So the view controller is removed from memory. Then when the view controller is removed, it takes its strong reference to the other object with it. So that other object is also removed from memory. We'll get more practice on when to choose strong and weak attributes as we're coding our app. Back in our code, no other objects are going to have references to this food array, and we want this food array object to never go away as long as our food table view controller is here. So make sure it's a strong reference. There's also a second part to declaring the variable, which is this synthesize line, and we need to add that to the .m file. Great, so now we can use the food array variable in any of our methods. The first thing we should do is initialize it to something. When we created variables in storyboarding, they are automatically initialized to what we connect to in storyboarding. But since we created the food array variable in code, it will be nothing or nil until we initialize it in code. ViewDidLoad is one of the first methods to get called in our view controller. So I'm going to initialize our food array in that method. The initWithObjects method initializes our array with a list of objects. Let's add some NSString objects that are food names. The documentation for this method states that we need to end the list of objects with nil, so make sure to leave that there. Now when the table view is loading, we can just load the food array in order by picking out each item from the food array. Here's how we'll do that. Go to the cell for row at index path method, and we'll put the row number in a variable. And then we'll get the NSString object from the food array that corresponds to that number. And then we can set that string to the text label of our cell. So the first table view cell is at row 0. And the first item in an array has an index of 0. So our first table view cell will say pizza. The next cell will display the next item from the array and so on. So let's see how that works. And everything looks good except that we didn't load the last item in our array. That's because we have it hard-coded in our table view that we want 3 rows. Let's make the table view has the same number of cells as we have items in the array. To do that, go to the number of rows in section method and replace the number 3 with food array count. The count method for NSArray returns the number of items in the array. So now, no matter how many items are in our array, that's how many rows we'll have in the table. Let's make sure that works. Great, now we have all 4 food items from our array showing in the table view. But the only way we can change our food list is by hard coding it. And it would be nice if we could let the user use the app to add foods to that list. So let's go to our storyboard and add a way for them to do that. I'm going to drag a view controller from the objects library. This view controller will hold a text field that will allow the user to add a food and a button that adds the food when the user's finished. So let's add those objects. We need a button to get to this new view. So I'm going to drag a bar button item to the table view's navigation bar. And now I can go to the attributes inspector to configure that button bar to look like a plus button by changing the identifier to add. Changing this identifier doesn't add any functionality for us. It just changes the look of the button. To make the button function, I'm going to hold down the control key and drag from the bar button item to the view. And I'm going to select modal. Now, pressing this plus button is going to display this view in what's called a modal transition. Before, when we added views to the navigation controller, we would use push, which would keep the navigation bar on top and automatically add the back button to the navigation bar. A modal transition will put this new view in front of the navigation view, so we can't go back to the navigation view until this new view is dismissed, and we'll dismiss the view through code. Before we start writing our own code though, we need to create our own custom class of a UI view controller to control this new view, similar to what we did with the food table view controller to control the table view. To do that, I'm going to go to File, New File. And I'm going to choose a UI view controller subclass. I'm going to call it TAD Add Food View Controller. And make it a subclass of UI view controller. Click Next and then create the file. Now go back to the storyboard file. Make sure our new view controller is selected and select the yellow circle. And just like we did with the table view controller, I'm going to go to the identity inspector and change this view controller's class from UI view controller to TAD Add Food View Controller. Now we can write in the TAD Add Food View Controller files we just created to customize how this view is going to behave. Let's start doing that now by connecting the UI elements in our view to our code. Switch to the Assistant Editor and make sure TAD Add Food View Controller.h is shown in the code view. I'm going to create an outlet to the text field and call it Food Text Field. And I'm going to create an action for the button and call it Add Food Button Pressed. So when the button is pressed, we want to read what's in the food text field and then add that to our food list. So now switch back to the normal editing view and let's start writing code for our Add Food View Controller. Go down to the Add Food Button Pressed method. When the button is pressed, we want to read what's in the food text field and then add that food to our list. Let's start by reading what's in the text field. Now I want to add the food to my food array that's back in the food table view controller and then have the table view refresh to show the new entry. It would be nice if we could just write something like this. And then we could have food table view controller take care of adding the food and reloading the view. But there are two problems with doing this. One is that this add food view controller that we're writing code for doesn't have any reference to my food table view controller. Right now there's no food table view controller variable that's going to allow me to communicate with the food table view controller. So I need to create a variable and make sure that it points to the food table view controller. The other problem with this line of code is that my food table view controller doesn't understand this add food method because the add food method isn't defined in the food table view controller. So let's take care of these problems. First, let's go to the TAD add food view controller.h file and add the food table view controller variable. I'm making the variable week to avoid the problem of two objects retaining each other that we talked about earlier. Notice that Xcode is giving us an error here. It says TAD food table view controller is an unknown type name. That's because right now this file only knows about Apple's classes and it doesn't know about our custom TAD food table view controller class. So to make sure that our custom class is included, we'll add this code to the top of this file. Now our error goes away and we can use the TAD food table view controller class in our add food view controller.h and .m files. So now we're just left with this warning that says that we need to synthesize the property methods. So let's do that now in the .m file. So now we have a variable for our food table view controller, but it's completely empty because we had never set it to anything. The easiest way to set this variable is actually back in the food table view controller. Before storyboarding performs a segue between two view controllers, it calls the method prepareForSegue in the view controller that's displaying the current view. So we can define this method in our food table view controller and then use it to set the food table view controller variable in the view that's about to be displayed. So go to the TAD food table view controller.m file, choose anywhere you like, and define the method prepareForSegue. Xcode's code completion should fill in the syntax for you, and then we can customize this method to set our variable. But again, we have the problem where we don't have a reference variable to access the add food view controller, which is where we want to set our variable. However, this segue object that's passed into this method has a property called destination view controller, which is a reference to the view controller that is about to be displayed. So we can access the add food view controller through that. And again here we'll need to import the addFoodViewController.h file into this file so that the TAD addFoodViewController class is defined. Great, so now we have a reference to our addFoodViewController. We just need to set its foodTableViewController variable by using the setFoodTableViewController method that's automatically defined when we created our food table view controller variable using the @property command. So right now we're writing code inside the table view controller, which is what we want to pass on to the add food view controller. The way an object can access itself is through the keyword self. So we can just type self here to set the variable in addFoodViewController to be this food table view controller. So recall that the whole reason we're doing this is because when the add food button in the addFoodViewController is pressed, we want to be able to call the addFood method and then have it take care of everything. So now we have a reference to food table view controller. We just need to declare and define the addFood method in our food table view controller. Go back to the TAD food table view controller.h file and declare the method. This method will accept an NSString object, which is the new food object that we would like added to the array. The reason we declare this method in the .h file and we didn't declare the prepareForSegue method in the .h file is because this is our own method, whereas prepareForSegue is a method that's already defined in UI view controller and we're just overriding it. So now define the addFood method anywhere you like in the .m file. When we created actions, Xcode would have generated that code for us, but here we're defining our own method that's not attached to a button. It can be called by any object in the app. Let's add some NSLog code here to make sure everything works the way we think it does so far. Great. When we press the plus button, our food table view controller's prepare for segue method gets called, which sets the food table view controller variable in our add food view controller. And then when we press the add food button, the add food method back in the food table view controller gets called. And I can see that because I see our nslog statement down here in the debugging console. Great, so now let's make the add food method actually add a food and display the new food in the table view. Before we do that, go to the documentation and look up NSArray. You'll see that there's no method here to add an item to an array. That's because an NSArray is a static array that can't be changed. If we want an array that we can change, then we need a subclass of NSArray that Apple provides, which is called NSMutableArray. It's described in the first sentence here in NSArray, so I'm going to click on that. And I can see that NSMutableArray has the methods I'm looking for where I can add an object to an array. So if we want to add objects to our food array, we need to change it from an NSArray to an NSMutableArray. So let's change that in the .h file. And now we also need to change it in the .m file where we initialize the array. Since NSMutableArray is a subclass of NSArray, we know that our new mutable array can understand all the methods that the old NSArray could understand. So we can leave this initWithObjects method the same, and we can leave all the other methods that we call on food array like count the same as well. So now to add a food, we just need to add one line to our add food method. Our custom method gets past the new food string, and we add that to our mutable array with the addObject method. So now we just need to reload the table view to display the new list. So our food table view controller is a subclass of UI table view controller. So let's look up UI table view controller in the documentation. We can see that it has a property called TableView that returns a UI TableView object. And if we look up UI TableView, we can see that there's a method called reloadData. So it seems like we should be able to reload the data in the TableView by going to our addFood method and typing TableView reload data. But Xcode gives us an error that says unknown receiver. It seems like we should just be able to access the table view variable because when we create our own variables with the @property declaration like food array, we just call them like in the food array count method. The reason we can't do that with table view is because Apple's UI table view controller class hides direct access to this instance variable. So Apple wants us to access it by calling the TableView method. So we can change that line of code to this. Remember that self is a reference to this object. So if we had a custom TableView method defined somewhere else in this file, that method would be called. We don't have a custom TableView method, but we know that this object can understand the TableView method because it's a subclass of UI TableView controller. And that defines TableView as a property. It's actually good practice to almost always access variables through their getter methods like this, all the time, even if you declare them yourself. The reason is you can customize the getter method to do something every time an object tries to access this variable. And Apple could be doing that when we access the TableView variable. So we'll do this from now on. So the last thing we need to do is hide the add food view after the view is added so we can go back and see our table view with the new value. We want to do this when the user taps the add button. So let's go to the add food button pressed method in TAD add food view controller and add this code. So we're calling the method presentingViewController on our addFoodViewController. When you choose to present a view with a modal transition like we did with this view when we chose modal in storyboarding, the view that's presented will have a presentingViewController. To dismiss the view, we just need to tell a presentingViewController to dismiss it with this dismissViewController animated method. So now let's run the project and add a food. Great. So in the next lesson, we'll learn how to input and display more information about the foods and then save that information so when we close the app and open it again, the foods that we added are still there. For the challenge for this lesson, try to add the ability to delete items from the table view by swiping to delete them. I'll give you a hint in that a lot of the code you need is already in the TAD food table view controller. You need to read the documentation for each method and then uncomment the code that we need. You can uncomment a method by deleting the /* pairs that enclose it. After uncommenting the right code, you'll need to add one line of code to make everything work. If you get stuck, try to use nslog to help you debug. And if you get an error message that you don't understand, try searching Google for some of the keywords in the error and see if that helps you work towards the answer.